In this example, we need to convert the analog filter that has the following response to digital low-pass filter with 3 dB bandwidth cutoff frequency at 0.3 pi. So this is actually the value of omega C, the cutoff frequency. So in the frequency domain of the analog filter, omega C corresponds to this one. So this is omega or omega C, which is equal to 2 over T as the sampling period multiplied with tangent omega C divided by 2. So we use the value given for omega C 0.3 pi in this equation to determine the omega C. So we have 1.02 divided by T as the sampling period. Therefore, we can substitute the value of omega C in this equation of frequency domain in S domain. So we have this equation after we substitute the value of omega C. The next one, we apply the bilinear transformation where we convert from S to Z domain. So based on the given equation that we have discussed previously, so this is the equation of frequency response in Z domain after we substitute S with this function of Z. Therefore, we have this equation from S domain, the frequency response in S domain. So we need to substitute this function with this one. So S is equal to this one. So the next one, after we substitute this equation into this equation of frequency response in S domain, we have this equation. And after we simplified and rearrange this equation, we simplified into one equation in numerator and one equation in denominator. We have this function of frequency response in Z domain. So this is the S function that we substitute based on this equation. And from this one to this one, to simplify, we need to refer to the monograph, page 155. Therefore, we have the magnitude of frequency response where we convert from Z domain to frequency domain omega. So we use this equation where we replace Z with exponent j omega. So from the previous frequency response in Z domain in the previous slide, we substitute Z with exponent j omega into this equation. And this one, we use this Euler's identity equation, cos omega minus j sin omega. And from this one, we can determine the magnitude of the frequency response of H exponent j omega equal to this one, based on this equation of frequency response. So this is the magnitude in frequency response. So this is based on the real part of this frequency response, and this is based on the imaginary part of the frequency response equation. So the next one, based on the frequency response equation, we have to calculate for omega between 0 until 180 or pi for this equation, based on this equation of the magnitude of the frequency response given in the previous slide. And also the next one, we need to determine the value in dB by using this equation 10 log. This is from the magnitude of the frequency response squared. So this is the value in dB for frequency from 0 until pi. So in this case, the range between 0 and pi we use as suggested value from 0, 0.1 pi, 0.3 pi, 0.5 pi, 0.7